Okay, so picking up at question number 26, we're moving on to the quadratic formula questions. Again, you'll be provided with the quadratic formula for your questions. My apologies if I am sneezing through this video. Apparently I'm coming down with a little sniffle. So let's get right into it. So quadratic formula, the first thing you got to remember, make sure that it is equal to 0. And basically you're plugging in numbers, folks. So you've got your A here, your B here, and your C here. Just make sure you watch your signs very carefully. So we would have negative of negative 11 plus or minus the square root of negative 11 squared minus 4 times A is 3 times C is negative 4. All of this divided by 2 times A. So if we go ahead and work this out, double negatives out front makes that a positive 11 plus or minus the square root. 11 squared is 121, and then you have negative 4 times 3 times negative 4, which is positive 48. All of this divided by 6. Add up what's under your radicands. You have 11 plus or minus the square root of 169 over 6. Well, the square root of 169 happens to be a perfect square, happens to be 13. So this means we have 11 plus or minus 13 over 6, which means we have two equations. We have 11 plus 13 over 6 and 11 minus 13 over 6. And if we finish those both out, well, 11 plus 13 gives us 24, so 24 over 6, which would come out to be 4. There's our first answer. And 11 minus 13 would be negative 2 over 6, which would reduce down to negative 1/3. Now in problem 27, which we said was one that you definitely want to make sure you keep an eye on, we're going to need to have everything on one side of the equal sign. Now because this x squared happens to be negative, I'm going to process and move everything to the other side of the equal sign. I'm going to make it equal 0 on the right side. So that means we're going to have a positive x squared. No, I'm sorry, we're going to have a positive 6x squared because we would add that 1 to the 5. 9 minus this 5 would give us positive 4x to the first. And then a minus 1 equals 0. So we're going to work with those numbers as our A, our B, and our C. So we would have negative, whoops, got my extra negatives in here, y'all. So we would have negative 4 plus or minus the square root of 4 squared minus 4 times A is 6 times C is negative 1. All of this divided by 2 times A, which is 6. So that would leave us with negative 4 plus or minus the square root. Slide this over here. We would have 4 squared would give us 16. 4 times 6 times negative 1 would give us 24 and make it positive because we have double negatives here. All divided by 12. Well, 16 and 24 would give us 4 plus or minus the square root of 40 over 12. Now 40 is not a perfect square, so we need to simplify the square root of 40. Well, that would be 4 times 10. Take the square root on both, which would simplify into 2 square root of 10. So we would have we would go to then next to 4 plus or minus 2 square root 10. Sorry about that. 2 square root 10 over 12, and if we look at all of these numbers outside of radicals, all of those can be divided by 2, so we would get 2 plus or minus the square root of 10 over 6 as a final answer, and that would constitute both of your answers for that last part. Okay. This problem here, you've got your choices. Again, You can do completing the square, you can do quadratic formula. My suggestion would obviously be to go to quadratic formula, and this would be a very good question. This is similar to question on some of the other study guides that say x squared minus 6x minus 15 equals 0 that we put for completing the square. It is your call how you choose to do this. You can factor this. This actually would factor into x minus 5 times x minus 5, which would give us both answers of 5 as a double root. Again, your call. If you want to do quadratic formula, you'll get the same answer either way. Let's go to the next section here. We will have a story problem, however, it is probably not going to be that one. So we're going to jump down. We did take the discriminant question since we brushed on this idea of discriminant, so we're going to keep moving forward here. We're going to jump to the simplifying expressions questions. This is your exponent properties, so remember, similar bases, different exponents, you're going to add the exponents, so this would be 5 to the 8th power. If you had to calculate that all the way out, we would be looking at 390,625. Single base to a double exponent, we would multiply, so this would be 7 to the 8th power, otherwise known as 5,764,801. Again, these answers would be perfectly acceptable. For 34, we have a negative exponent, which means the first thing we need to do is we would need to flip the fraction and drop the negative, and then take the exponent and put it to both the numerator and denominator. So we would end up with 5 to the 3rd over 4 to the 3rd, and if you calculate that all the way out, you get 125 over 64. Then we get into the variable problems. Again, multiple bases, different exponents, keep the bases, add the exponents. Well, 5 plus a negative 4 is a 1, negative 7 plus 9 is a 2. And that would be your final answer. In a question like 36, the way that we've talked about this before, first things first, we would get rid of any negatives, or any zero exponents, I'm sorry. The second thing we would want to do is we would want to look at whole numbers. We want to simplify what's in the parentheses before we distribute. So 16 divided by 4 would just be 4 over 1. We have r to the negative 6 and r to the 7th. Well, negative 6 minus a negative 7 comes out to give you a positive 1. So I'm going to have r to the 1st, and it's positive, so I leave it up top. Now this q to the negative 3, we don't want to have a negative, this q negative 3 right down here, we don't want to have a negative in our denominator, so we're going to bring the q3 up top so it becomes positive. There's still a 3 exponent on the outside, so the 1 on the bottom is really no longer needed. Now we just need to make sure, remember, the 4 has a 1 exponent on it. Let's multiply all these exponents, so we get 4 to the 3rd, r to the 3rd, and q to the 9th. The only thing left to do here is to simplify. 4 to the 3rd would be 64, r to the 3rd, q to the 9th. And again, similar process in 37, but we don't have the parentheses to deal with. We have the 2 on the bottom, which it doesn't have an exponent on it, so it's going to have to stay where it is. We have a to the 2nd over a to the 3rd, which means there is one more a in the bottom than there is in the top. This b to the negative 1 needs to drop down, so we're going to move that down. But that means if I bring this down here, I have b to the 2nd and b to the 1st, so I have b to the 3rd, and nothing left up top, but I need to hold its place. So we're going to end up with 1 over 2a to the 1st and b to the 3rd. Moving into our scientific notation questions, again, you've got your leading numbers here, and then you have separately your powers of 10. So Multiply your two numbers out front. 5.4 times 2.5 is 13.5 times 10. Add up your exponents. That would be a negative 3. Now, scientific notation, remember, can have a negative exponent. The only thing it can't have is this leading number has to be a number between 1 and 10. Right now, it is not. So we need to move this decimal back one place and add 1 to the exponent. So we would get 1.35 times 10 to the negative second. Similar process when we divide. We take the numbers out front and we divide. 1.56 divided by 4.03 is roughly speaking 0.387. If we then subtract the exponents, we're left with times 10 to the 11th power. But again, this is not in scientific notation. But we need to move this decimal the other direction, so it is 3.87. But if we move to the right, we need to subtract. We need to subtract 1 from the exponent. So this would be times 10 to the 10th power. And that would be our final answer there. Okay, on to the next page. The next part is our addition and subtraction of polynomials. Remember here that really all you're doing is you are adding up like terms. So start with your highest exponent. So I have 4x to the third minus 5x to the third. So I get negative 1x to the third. That takes care of those. I have 4x squared minus 2x squared, which would be plus 2x squared. Got rid of those. Negative 3x plus a negative 4x would be a negative 7x. Got rid of those. And 10 plus a negative 4 would be a positive 6. Same idea with 42 again, but this time we have a subtraction problem. I've told my students, change the sign to addition and change all of the signs after that sign change. Most of you know that is the keep change rule. So we're really going to look at an addition problem, but we're going to change the signs. So if we do that, run through this, we have 2x to the third plus a negative 3x to the third. Well, that would be again a negative 1x to the third. Got rid of that, got rid of that. 2x squared plus 4x squared would be plus 6x squared. Got it and got it. Negative 3x plus x would be a negative 2x. Took care of those two. And positive 5 plus a negative 7 would be a negative 2. For those who want some extra practice on these, I'll give the answers for these next two. Again, you're just adding like terms. You should end up here with negative 7x to the third plus 2x squared plus 2x minus 15. And here you should end up with 9x squared minus 4x minus 6y minus 6. Keep in mind that these terms do not match, so they both have to be part of your answers, and typically we go in alphabetical order. Okay, moving on to the next part, which is something that will most likely show up on your exam. This question right here, question 44, on some of the study guides I believe this is question 42, but again, this is the distributive property. You are multiplying a trinomial times a binomial. So we're going to take every term in here and multiply it by the binomial. So 3x squared times 2x would give us 6x to the third, and 3x squared times 3 would give us plus 9x squared. Now we're going to take the second term. So now we're going to take 3x times the binomial. Well, 3x times 2x would be 6x squared. Notice I'm stacking the x squareds under each other. 3x times 3 would be plus 9x. And then our last one, we're going to take the 5 times 2x, which would be 10x, and 5 times 3, which would be 15. We're going to draw the line underneath here, and we're going to add straight down. So we get a final answer of 6x to the third plus 15x squared plus 19x plus 15. And that would be our final answer. That's the simplest way to deal with these. For a problem like 45, you have a choice. You pick any two of these that you want to start with, and you're going to FOIL them the way we would normally FOIL. I'm going to choose to pick the two addition problems. I'm going to actually FOIL these two together at first, because to me the addition signs means I make less chance of an error. So let's run this through. X times x would be x squared. X times 6 would be 6x. 2 times x would be 2x, and 2 times 6 would be 12. Combine up like terms, so now we have x squared plus 8x plus 12. We're going to put that all back in parentheses, and we're going to bring our third factor down, and we're going to redo the process we did just a few minutes ago. But this time we're going to take the binomial and multiply it by the trinomial. Again, not a big deal. We're going to take x times everything here. So that would give us x to the third plus 8x squared plus 12x. And then we're going to take 5 times everything, negative 5, I'm sorry. So that would give us negative 5x squared minus 40x minus 60. Line underneath, add straight down. We would end up with a final answer here of x to the third plus 3x squared minus 28x minus 60. The trick to a question like number 46 is remembering that when you have a binomial squared, it actually means that you are doing 2x minus 5 times 2x minus 5. You're going to FOIL. So 2x times 2x would be 4x squared. 2 times negative 5 would be negative 10x. You get the same thing in the middle. And the last two would be plus 25. Our final answer then would be 4x squared minus 20x plus 25. Now we take it from that into the section on factoring. Now, most definitely you are going to want to look at a question like number 47. The reason being, this is a sum of cubes. So the formula that you will have provided for you for sum of cubes will say a plus b times a squared minus a times b plus b squared. Your job is to simply remember what is a and what is b. Well, in this case, my a is the cube root, okay, the cube root of 8x to the third. Well, the cube root of 8 is 2, the cube root of x to the third is x. And the cube root on 27 is 3. There's your a, there's your b. All you're doing is plugging into the formula. So we would have 2x plus 3. Then we would have 2x squared, which would turn into 4x squared, minus a times b, which would be 6x, plus b squared, which would be 9. And that would be our final answer. You would obviously want to check and make sure that that last equation doesn't FOIL, doesn't factor itself, but in most cases you shouldn't have to worry about that. In number 48, you could factor this a number of different ways. The easiest way to deal with this, because it's really just both squares, is that x to the fourth is the same thing as x squared times x squared. 16 is 4 times 4. Put 1 plus, 1 minus. Now, this minus factor keeps going. So we break that apart, because that would factor into x plus 2, x minus 2. Bring down your third factor, and you have your final. Again, the question out of these two I would really concern yourself would be question number 47. Then we move into the factoring by grouping. Definitely want to make sure that you focus. Questions like 49 and 51 are both factoring by grouping questions. I think both are good examples of what you might be likely to see. These are the ones where we drop the line and we take the greatest common factor on each side. Well, the greatest common factor between x to the third and 3x squared happens to be x squared. Okay, so x squared, if we multiplied that by x plus 3, it would get us back to the original. On the right side, the greatest common factor is 2, which would leave us with x plus 3. And again, once you have a common factor here, then you're ready to group things together. So you group together the two GCFs out front, which would be a factor of x squared plus 2, because it's a positive 2, and then you would group together your common factor of x plus 3, and your question would be done. Problem 50 here is another sum of cubes. However, in this case, we actually needed to factor out the 5 first as a GCF. So then our a would be just the variable x, and our b would be the number 1. So in our old formula we did just a moment ago, we would have a plus b times a squared minus a times b plus b squared, and we would put our 5, our greatest common factor, out front, and we would be done. Moving into problem 51, again, it's a 4-termed equation, so we factor by grouping. Greatest common factor on the right is on the left, is x squared, which would leave us x plus 7. Greatest common factor on the right would be a 4. If I divide both terms by 4, I'm left with x plus 7. Group together your leading numbers, which is x squared plus 4. And group together your common factor, which would be x plus 7, and you would have a final answer. Definitely both the grouping questions, I think, are worth your time to review and look back over. The division questions, again, I think as long as you're comfortable doing either synthetic or long division, you will be just fine. We'll run through one of these with the long division and give you the answer for the other one just in case. So in this case we have, whoops, my apologies. We have a divisor of 2x minus 1, and we're dividing that into 4x to the third. I'm going to leave a placeholder of a 0x squared because that term is missing, minus 7x plus 8. And I'm going to do our scratch work over here. So we're going to use 2x for all of our scratch work. So the first part of this, 2x times something, will give me 4x to the third. Well, that missing piece would be 2x squared. That's what's going up top. Now we're going to take that 2x squared and we're going to re-multiply it by our divisor of 2x minus 1. So if I distribute that, I would end up with 4x to the third minus 2x squared. Draw your line, change your signs. First term should cancel. Second one's turn into 2x squared. Bring down your next term, minus 7x. So the next step in the scratch work, again, we start off with 2x times something. This time has to give us 2x squared. Well, I already have the 2 to speak of, so I don't need a whole number. So in order for me to make an x into an x squared, I need to multiply by x. So that's going to be my next part of my answer. So we'll take the x times our divisor, 2x minus 1, and distribute. So that's going to give me 2x squared minus 1x. Draw your line, change your signs, cancel the first ones out. Negative 7 plus 1 would end up giving me a negative 6x. Bring down your next term, plus 8. So our last set of scratch work is going to have 2x times something has to give me a negative 6x. Well, the only number 2 times what would give us negative 6? That would be a negative 3. So if we remultiply negative 3 times 2x minus 1, we would get negative 6x plus 3. Draw the line, change the signs. The first term should cancel. 8 plus a negative 3 gives me a remainder of a positive 5. So we write our final part up here of plus 5 over our divisor of 2x minus 1. And I'm just going to highlight all of that in yellow because that is our final answer. Here we go. So you would follow the same process for problem number 53, but 53, again, it has a remainder. You should have come up to x squared plus x minus 2 plus 3 over 3x plus 1. Again, the only time you really need to be comfortable doing long division, whoops, didn't mean to do that, is if this divisor has either an exponent, okay, let's zoom this in, if that divisor we highlighted in green, if that x had an exponent higher than 1, or when it has a leading coefficient other than 1, you are trapped kind of into doing long division. Now, that doesn't mean you're going to have to necessarily do long division because here we have some synthetic division problems. So let's run through synthetic since that's what the majority of people will usually choose in the long run. We want to make sure when we do synthetic division, we want to make sure that we have all of our leading coefficients in the box. So we have 2, negative 7, negative 1, and negative 12. And the only thing you have to remember is if this divisor is written as a factor, then the number you put out front has to be the opposite sign. So let's run through synthetic. First number drops down and we multiply. 4 times 2 is 8, and we add. Negative 7 plus 8 is 1. 4 times 1 is 4. Negative 1 plus 4 is 3. 4 times 3 is 12, and negative 12 plus 12 is 0. So this thing has, that's my remainder, my constant, my x to the first, my x to the second. So my answer for this problem would be 2x to the second plus 1x plus 3. No remainder, therefore no reason to write a remainder. In problem 55, again, we're doing synthetic division. So we're going to have 1 for our first leading coefficient. Then we have negative 5, but then we jump x to the third, then we jump to a regular x, which means I need a placeholder of a 0 because there is no x squared term. Then we've got 4 and negative 17. The number out front, remember, we're going to change the sign here, is going to be a positive 5. So let's run it. Bring down your first number, multiply. Gives us 5. That gives us 0. 5 times 0 is 0. 0 plus 0 is 0. 5 times 0 is 0. 4 plus 0 is 4. 5 times 4 is 20. And negative 17 plus 20 is a positive 3, which means this problem has a remainder, a constant, no x to the first, no x to the second, but it does have an x to the third. How I would write this, I could put the 1 in there, 1x to the third plus 4, skip over the 2 that are blank, and that doesn't have an x on it, and then we have a remainder, so it's going to be positive 3 over x minus 5. That would be our final answer. Okay, so when we get to given one factor of the polynomial, factor it completely. Remember, this is synthetic. where they're telling me that if I use this term in synthetic, I should get a 0 at the end. When I get that 0, then I can either factor with my puzzles, with my 4-square box, with the quadratic formula. I have lots of options here. But again, we're looking for the factors. I don't want the zeros right now, I want the factors. So let's run the synthetic with what we have right now. We're going to use a positive 3 out front. We'll have 1, 3, negative 34, and 48 on the inside. Drop your first number down, multiply, add, multiply, 3 times 6, going to give us 18. Add them up, we get negative 16. 3 times negative 16 is negative 48. And oh, good thing we get 0 there. So now, this equation is 1x squared plus 6x minus 16. We have to think about, does this factor? However you choose to factor something, again, whether it be your puzzle, whether it be your 4-square, whether it be your quadratic formula, you're going to have to pick which method's best for you. At this point in the game, we can't really tell you there's a method that you must do for this problem. I personally would choose just to say, okay, I can factor this by guess and check, because x squared is just x times x. I need numbers that multiply to give me negative 16 that are going to add to give me a 6. Well, the only numbers that multiply to give me 16 are either 4 and 4 or 8 and 2. And I think about 8 and 2 as being, well, 8 minus 2 would give me a positive 6. So there's my other two factors, and all I'm going to do is bring down the one they gave me in the beginning. And there's my 3 factors. Alright, we're going to pause this and start on a new video because we're at about 31 minutes here.